This is the video tutorial for the Core and Shell O3 assignment. I'm here in the final deliverable at the last page of the northeast exterior view. As you can see here, we're going to be adding a certain level of architectural detail to our walls, including these cast stone and colored brick bands. We're also going to be adding the membrane roofing systems as well as our patio deck. So this architectural detail that we're adding to our walls helps break up the large expanses of these flat brick walls. This is a common method in architecture to add visual interest and make our building less monotonous and boring. We're going to be doing this with bands of different colored bricks and cast stone accents. There's several ways to do this in Revit, but the most applicable to our model will be using what Revit calls wall sweeps, which are embedded into our wall types. Essentially, wall sweeps are two-dimensional profiles or shapes that are swept or extruded horizontally or vertically through a wall's length or height. In our case, our sweeps will be horizontal, as you can see here. Some standard profiles for wall sweeps are included in the Revit architectural template, like sweeps that are exactly one brick in height, which we will be using. For other more distinct sweeps, such as our cast stone water table windowsill, we are going to be making our own profiles, which are essentially loadable families. So we're going to be delving into creating our own custom families in this assignment. The first thing I want to do is set down some reference planes that will help us not lose our minds later. Essentially, if I'm zooming in here because you can see that the face of this storefront wall below the window coincides with our current wall face. However, there's this little extension here, and just the way that Revit sees everything where we cut the first floor plan, that's going to cause some issues with our dimensions and what we actually see. As a little insurance, so that we can always find that, we're going to set up some reference planes. So I'm going to go to the reference plane command. It's also RP, and I'm just going to trace that north wall, and then I'm going to create another one, and I'm going to use the inference from that wall, and I'm going to bring this all the way down here, and then out here I'm just kind of going beyond the dimensions and setting these planes up. Now again, these don't print, but they are going to be very helpful later on. These are very handy reference planes that we can leave in this project, so we can rename these. So I can click on this and I can just call these north wall face, west wall face. I will name those reference planes that I don't want to delete. So south wall face. If they're just temporary, I don't bother naming them, and that's kind of a note to myself that they are okay to delete later if I don't name them. The next thing that I'm going to do is I'm going to start setting myself up to create 7 different exterior wall types. They're all going to be based upon our current exterior wall. So they are all going to have essentially the same structure. They're all just going to have different sweeps, which we haven't gotten into yet. So before I start developing those sweeps, I'm going to create those wall types. So to create those wall types, I'm going to the architecture ribbon wall, and I'm going to come in here. I've got my basic wall, exterior brick on metal studs. So this is my exterior wall type. So I'm going to edit wall type and duplicate. When you look at the instructions, there's 7 different wall types. I'm going to simply keep duplicating this over and over 7 times, giving that the name. Now you'll also notice the naming convention that I've gone with. I've kind of switched things up here to just talk about naming your family. So we're going to sort of create a standard here. We're going to call E for exterior dash O1 storefront base. So we're going to use this E with a number just to say basically exterior 1. And then a description here for storefront base. Now we're not actually changing the structure or anything yet. In fact, we're not even going to be changing the structure. We're only going to be changing the sweeps later on. So I'm just going to keep duplicating these until I have all 7 that are listed in the instructions. I'm going to do that off screen and then pick up from there. So now that I have all those wall types created, I can start adding the sweeps to them. But before we get to that part, I just want to show you what sweeps are. So I'm going to go to the wall button, and I'm just going to choose, let's start with our storefront base. This doesn't really matter, I'm just showing you the menu. We're going to click edit type and edit structure. Now again, this should look exactly the same for all of our exterior wall types that we've just created. We, however, want to look down here. We want to see our sweeps. This is grayed out because, as you can see, this modify vertical structure panel is only available when the section preview is on. So we need to turn on the preview, and then we need to change the view to see this wall in section. So the previous one was plan, this is section. Now our sweeps menu is activated, we can click on it. So the sweeps, we can add as many sweeps as we want, and we can set the distance of the sweep from the bottom or the top of the wall. We can change the profiles, so what's the shape of the sweep, the material, and all sorts of other things that we'll get into later. In order to populate this, we have to have the profiles created. Some of the profiles we're going to be using are in this template by default. Some I'm going to provide to you on our course homepage as downloadable files. And one of them we are going to create from scratch. So that's what we're going to do here now. So cancel out of these dialogues. To create a custom profile, we need to create a new file. So we're going to go to File, New, but we want to click the right arrow. And we want to choose family this time. So we're creating a custom family. And just like we choose a project template when we're starting a project, when we're starting a family, we need to choose the right template. So we're going to go into English Imperial, and this is a profile. We'll talk more about this later in the semester, but for now I want to come down to the profiles. Now there's a bunch of different profiles here. I'm just going to choose the generic profile. Hit open. This is going to open the profile template. And all of the necessary things that we need to create a two-dimensional profile are in this template, including, as you can see on the screen, these two reference planes. Where these two reference planes meet is the insertion point of our sweep. We want to reference this water table sill sweep from the bottom. So we are going to align it with this horizontal. And for the purposes of this sweep, we can consider anything to the right side of the vertical line to be the exterior face of the wall. So this vertical line is the exterior face of our brick wall. So we're going to create a profile based upon the image in our instructions. What we want to do is basically draw a line. So we're going to pick the line command, and I'm going to start down here, and this is going to go up 1'4" because that is the sill height. Now we also have to think about the fact that this goes down 8 inches below grade. So we need to take 1'4" plus 8 is 2 feet. So we're going to draw a vertical line 2 feet tall. Bottom of this, so I'm going to go back to the create line tool. I want a line at the top here, 1 inch. So I have a 1 inch overhang of my sill to the exterior. So that's easy enough. I can choose the line and I can do the offset, and I'll do 1 inch. And I'm going to trace this line down 5 and 11/32 of an inch. Now that's, for all intents and purposes, 2 brick courses in height, rounded to the closest 32nd of an inch. So now I can come in here, I can create a line from here over, and the total width of this thing is 6 inches. I can come down here now to this reference point. We're going to come over from the back 1 3/8 of an inch, and then go straight down to our baseline, finish that, bring this over, and then trim this up so that we have a continuous loop. Much like many things that we create in Revit, this needs to be one continuous loop to create a profile. We could start adding dimensions in here, and then we could create parameters to drive those dimensions. That would make this family reusable. We could create variables or properties for all these dimensions that we just inputted, and we'd have an infinitely useful water table sill profile. Now we don't need to do that for this project. We just need this one profile. So this is a family that only has one type within it. So this is the family, and this is also the type. So we're going to save this. Save it in your folder where you're saving all your files. So we are going to save this, and we're going to call it wall sweep water table sill. I try to be as descriptive as possible with these names. Now you should save this in the folder where you're saving all your drawings. I'm saving it in my own folder here. Once you save that, you can hit load into project and close. And now we've created a loadable family profile and we've loaded it into our project. So now it's available to use as our wall sweep. So that we've just created our first custom family. Now the other thing that you're going to want to do is load in the parapet cap profile family from our course homepage, as well as the fascia flat roof profile, which we're going to use later when we create the roof. So now that I have that profile created, I can start working on creating my wall sweeps. But before I do that, I'm going to start creating my wall sweeps at this lower piece of wall here. Now that is our storefront base, and if you look at your instructions, you can see these graphics that show that storefront base happens below all of our storefront windows. What I'm going to do is select all of these walls. I'm holding control so I can select multiple things, and I'm going to select all of these walls that are below. And now I can go to my type selector and I can set this to E01 storefront base. So now all of these walls are of that type. So now if I modify this type, they will all be the same. So now I'm just going to select any one of them, edit type, edit structure. And again, I have to turn on my preview and I have to set that to section if that hasn't already been set in this current session of Revit. So I'm going to hit sweeps. This time I'm going to hit add. I now have that profile loaded in. I can click here. I can come down and I can find wall sweep water table sill, if that's what I named it. If you named it differently, you might have to check your name. But this one I named wall sweep water table sill. It actually says that twice. It's because we only have one type within the family and they're both named the same. So we can click that. The material for all of these cast stone pieces, so this water table is of the cast stone material. I'm actually just going to use precast concrete. They're similar and I'm not going to bother creating a new material just for this. So I'm going to choose precast concrete, hit OK for the material. The distance is 0 from the base, so that's already set. In fact, the rest of this is all set. I don't need to change anything else other than the profile and the material. When I hit OK, you'll notice that that profile now shows up in my section preview. So now I can hit OK, and then I can hit OK again, and now you'll see that all of my storefront base walls now have that profile extruded along their path. And you can actually see here at this door jamb that the top is 1'4" above the finished floor, and plus that 8 inches below the finished floor equals 2 feet. So the entire height of the wall is just made up of that wall sweep. I'm going to show you one more wall and how to set up those sweeps, and then the rest you can do on your own. So again, what I'm going to do is select all of these walls. So I'm just going to go right to the storefront middle, and I'm going to select all of those pieces. Because I have all of these constraints, these keep coming up when I select these walls, and sometimes it might be like, oh, I accidentally selected a constraint. You can always check what you have selected by coming down here to the little funnel icon on the status bar, and that's the filter button, and we can see that we only have walls selected, so we're good to go. I can change my type to storefront middle, and again I can now edit type, edit structure, click the sweeps button, check this sweeps menu in my instructions. So let's scroll up until we can find storefront middle. Now this only has 2 sweeps. These are wall sweep brick course 2 bricks. They're precast and they have some dimensions. So I believe I already have this profile loaded, and in the default template there is a profile called wall sweep brick course, or wall sweep soldier course, or brick soldier course. Do not use that one. You want to use the single brick course, and I don't believe that's loaded in the template file. What you can do from the sweeps menu is hit this load profile button. It'll take you to the families folder, and we can scroll down till we find profiles, wall, and we want the wall sweep brick course, and we can open that. Now it's going to ask me to overwrite it because I think I already have it loaded into this project. So now I can change this. Our wall sweep for this is, I believe, 2 brick courses. So you can see this brick soldier, we don't want that. We want single wall sweep brick course 2 bricks. The material again is going to be precast concrete. It remembers our last selection, so that makes that quicker. This first one is at the bottom, so it's 0 from the base. Before I set anything else, I'm just going to hit OK. And you can see that unlike our own profile that we created, this one seems to be flipping it to the opposite side of the wall. So it's its orientation is backwards. And that just happens sometimes. Whoever created this profile for this sweep just basically had a different idea of what was interior and what was exterior. So what we need to do is we need to move this into the wall, and this sweep is 3 5/8 inch deep because it is, you know, a brick sweep, and our brick is 3 5/8. So we need to move this into the wall by 3 5/8 of an inch. So if we go back to our sweeps menu, we can set our offset to 3 5/8 of an inch. If we hit apply, we can actually see that happen. Now that moved it away from the wall, so we know that this offset should actually be negative 3 5/8. And if we hit apply, now that sweep occupies the brick. We're going to add the second one, which is also a brick course 2 bricks. It is also precast. The height for this one is 6 foot 11 and 256ths. Now I know that's a weird dimension, so I'm going to put in, sorry, the distance, 6 foot and what was it, 11? 11 256ths. Now I got that dimension from measuring the coursing lines. So those brick coursing lines, to get this in the right spot, I went out, dimensioned from the bottom of this wall to the top of this wall, minus 2 bricks, and that's the dimension you get. Does it really have to be that accurate? No, not really, but that's just what the dimension came up, so that was the easiest thing to put in. Now my offset on this one, this brick is going to stick out of the wall by 1 inch. So if we had to get this one back negative 3 5/8 to stay flush with the wall, we need to set this one to negative 2 5/8 of an inch. Now you don't have to kind of figure that out. Like I noted, these are all within the instructions. So each of these shows you the sweeps menu for each wall type. But I just thought I'd explain what some of these numbers mean in the video. So we're going to hit OK now, and if I scroll out a little bit, I can see that piece of cast stone that's sticking out of the wall. So we can hit OK, and that height is based upon the actual height of our wall between the two windows. So when I hit OK again here, and I'm going to hit escape so I'm not selecting those, you can see now that we have a cast stone band at the bottom, or that I should really say at the top of this window, and a cast stone sill that projects 1 inch at the bottom of this windowsill. As I mentioned, I'm not going to go through every single wall sweep for every single wall. At this point, I've gone through 2. You can follow these instructions here and set those up for yourself. Once I'm done that, I will come back to the video and we'll continue from there. Okay, so now I have all of my wall sweeps complete. You may notice that the parapet cap on this wall is not showing up. That's due to a mistake on my part. I had the wrong height for these walls given in the first assignment, so let's fix that right now. I'm going to select all of these walls, and I'm going to change their constraints. So the base constraint of this should actually be referencing the second floor. Now this isn't actually going to change the height of the bottom of this, but we're going to change that to second floor. And again, the offset is the sill height, which is 2 foot 8 plus 10 feet, so that's a 12 foot 8. So we're going to change our base constraint to second floor, and the base offset is 2 foot 8 plus 10 feet, so that's 12 feet 8 for the top of those windows. And then the top constraint is up to level top of parapet framing low, which is correct. So we are going to apply that, and it's not going to fix our problem. The problem is our top of parapet low is at the wrong height. So let's go to a north elevation, and I've hidden that in this north elevation. So let's unhide it by using our Reveal Hidden Elements button on our view control bar. So now I can find that top of parapet framing low, and I had mistakenly put it in the directions as 35 feet 4. It's supposed to be, I believe, 1 brick course higher, which is, or maybe 2 brick courses higher, 35 feet 9 and 3/8. I'll turn off that toggle reveal hidden elements, go to a 3D view, and now you see that we now have the parapet cap on top of that wall. Again, I'll go back to my north elevation. The other thing that that should do is it should change this dimension so that it's a nice even 6 feet to the top of that wall. Now the tops of these walls are actually measured to the bottom of the parapet cap because that's where the framing for that wall would be. Now I'm also noticing in the video I had made some other changes outside of the video, and one of those was the colors of this brick. So let's take care of that now. Yours will probably be red at this point. To change the materials, we're going to go to Manage, and the first button on the ribbon is the materials button. We've gotten into this menu in other ways, but this is just another way to do that. So we are going to search for brick, and that's going to give us this brick common. And if you look at the instructions, all you have to do is set the RGB value to be different for this particular material for this brick. So brick common is RGB value 138.109.93. And you can see that here. To change this, you just click on the color itself, and right here you have the red, green, blue, so that's 138.109.93. You set that. We also need this brick common 1 to create these other color bands, so you might actually have to do this step before you create the wall sweeps that have that other color, otherwise you might have to use a placeholder. So to do that, you would hit the create and duplicate button, so this little sphere with the plus down here, you click that while you have the one that you want to copy, so you would select brick common and you'd hit duplicate material and assets, and by default it just adds this one. I've just left it to be the same name. We could name this something else, but we'll just call this, brick common 1, and then that one gets changed to this RGB. It's 877669, and again that's in the instructions on what the color is for this particular material. After you do that, the color of your building should be a little bit more subdued, more of a brown color than a red color. So now we are going to start putting the bands on our fin walls for those materials. I'm going to start with this western fin wall. Now there's also, I also caught an issue here. The original height of this wall was given incorrectly as well. The top extrusion was shown at I think 3 feet 4 above the roof level. It's actually supposed to be 4 feet above the roof level. So let's go ahead. I'm just going to throw a dimension on here now to see where it's at. Yeah, so it's some weird dimension right now. So I can come in. Maybe the easiest way to do this is with a reference plane. So I can do reference plane. I can set my offset to 4 feet in my options bar, and then I can simply trace the roof line. Now that's putting it below, so I want to hit the space bar. It'll offset it to the opposite side. So that's how tall it should be. Easy enough. Now I can just grab my in-place family and pull that extrusion up till it meets that line. I don't need that line anymore, and I don't need that 4-foot dimension. I was just trying to figure out what that should be. So that brings that up to the proper height so that we can now create these bands of different materials. Now the other thing that we didn't do is in the first assignment, we only brought these up, like I said, to the top of the framing. The parapet caps actually happen above this. What we need to do to this is add another extrusion, and those parapet caps are essentially 2 brick courses. So we need to add a new extrusion. Let me go to the 3D view to explain this. Our brick wall is hollow, but the parapet cap has to be solid to cover up that opening. So what we're going to do is go to the roof plan. We're going to select that in-place family. We're going to edit in place. And just like before, we're going to start a new extrusion. In this case, we're just going to do a rectangle and trace over the existing extrusions, and we're going to lock these so that they all always stay together. Because I started this on the roof plan, so it is roof plan. We know that the start of that extrusion now is 4 feet, and I'm just going to say 4'6" for now. I don't know exactly what 2 brick courses is. It's a weird dimension, so I'm just going to get that above a little bit, go back to a north elevation. Unfortunately, because this is, well, the other thing that I did was I made sure that this was, my material was precast. So it's got to align, it's got to be to a brick coursing. These brick courses don't appear to line up, so I'm somewhere in the ballpark, so I'm going to come over here. That looks like 2 brick courses. Again, we could always draw a reference plane. So RP, I'm going to go from the bottom of this thing, and then RP, go 2 brick courses up. It looks like these are on course, so I'm using those. So I did get that correct. So what is the top extrusion now end up being? 4'5" and 75 256. Again, it's much easier to just align it to a coursing dimension. And again, if I look at this in 3D, I can finish my model, and now you can see that I have a solid cap on top of that. Now that's going to have to happen to all of these. So I'm going to have 3 caps on this one, so there'll be a cap to either side at this lower height, and again, that's going to be 2 bricks heights in elevation. There's going to be a single cap on the top of here, and then over here we'll have a single cap, 2 brick courses in height. So now that we have that cap on this one, let's go ahead and go back to the north elevation. So to create these bands, I'm going to jump in my final deliverable. So you can see these bands if I zoom in, and down here again we have to create that band of cast stone or precast concrete, whatever you want to call it, at the bottom for our water table. Now we can't do that with a wall sweep because these are in place families, so we're going to use a tool called split faces, and it says that in the instructions here. We're going to split the faces, and then here we have the locations of all those splits. So for this west fin wall, now that we've got this all fixed and the top of parapet framing low is 35, 9, and 3/8 as it should have been, we are going to go up 5 brick courses. We're going to have 1 brick course of cast stone, 3 brick courses of brick, and then that cap which is already there. So we really just have to split this here and then at the water table. So to do that, like I said, I'm going to start on my north elevation. I'm going to turn on consistent colors so that I can see my materials. I'm going to select my in-place family, edit in place, and now I'm going to split face. So that's this button here on the modify ribbon, and I'm going to come down here and I'm going to click on the face that I want to split first. It highlights that face and it gives me some sketch tools. I am going to, well, it looks like my coursing is on track, so I can select line. So that's the select line tool or pick lines tool, and I can pick that coursing line that splits right at the top of my water table. So now I can come up here. Let's see, let's go back to this. It's 3 brick courses down, which is easier to figure out because we can go right there, choose that line and choose this line. And now we can check mark. So now we have 1, 2, 3, 4 different faces. And what we're going to do now that we have the separate faces, is go to the button below the split face tool, which is this paint tool. So we're going to click that. It will open this material browser. We're going to choose concrete precast. If that doesn't come up, you can always just search for it in the search bar. And we're going to click on the surface we want to add that material to. And then we're going to come up here to this band and paint that there. We can hit done. Now, if you find that your coursing is off again, you can always come in here and we can hit AL, and we're going to align this coursing to there. Now, that might not fix the solution. That did fix it here, but as you come up here, you can see that, oh, now this is off. And I can show you what's going to happen if I align this to this. It's going to mess up the coursing below. The way I found to fix that is to come back into your paint button, and even though the base material on these faces is brick common, I need to repaint that onto this surface, and it seems to fix the coursing issue, even though it kind of splits it up from these 2 faces so that they don't need to be aligned together. Or I should say the opposite, they actually seem to align together better once you do that. So I'm going to hit Finish Model to get out of my in-place family, go to my 3D view, and I can see that now I have those bands across the north elevation. Now, the drawback to using the Split Face tool is that I can only do 1 face at a time. Let's finish this out. Let's go to the west elevation, and again, I'm going to turn on my consistent colors. I'm going to select my fin wall, edit in place, split face, choose my face by clicking on it, and then picking my lines, and I'm going to let's pick that line, come up here, and again it was 1, 2, 3 courses down, and then 1 course. Can hit our green check mark, and now we can go to our paint tool, precast, paint tool, precast. Make sure you're clicking on the right face. So we'll put precast there, precast down here. We'll align our coursing, come back up and check this coursing, and if it's different, it is. We will go back to the paint tool, switch to brick common and paint that there, and that still didn't fix it, so now we can try to align this and it should move separately from this one, and it did, and we can hit the green check mark. So here's my fin wall. I'm going to, or sorry, my south fin wall. Let's look at that in the west elevation. We're going to edit in place, go to the roof plan to create our new extrusions. So I'm going to do these as, let's see, I'm going to do the two side ones just like I did before, where these two side ones are one extrusion, the upper one is a different one. So we'll do create extrusion, and I'm just going to do a rectangle over the top of these wings, if you will, and we'll lock those, and then we'll do another rectangle over the right side, lock those. Now I don't remember exactly how tall these were. I do believe they were more than 4 feet, but again, we can always adjust this later. Let's just do that. We'll go to our west elevation, and yeah, we're way too low, so I'm going to bring this up. Now these also appear to be on coursing, so I can bring this up, and it's kind of hard to see that. Okay, so that's that coursing line is the top of the existing one. So that extrusion is correct. We're going to go back to our roof plan, edit the in place family, create a new extrusion, and again, I'm just going to make this a single rectangle on top of the entire thing. I'm going to lock all 4 sides to the extrusions below, and this time I'm going to go, I don't know, 12 feet, 12 foot 6. Just to get it further up, we're going to hit the green check mark, go to the west elevation, and we're still not high enough, so we're going to bring the bottom up. Now this is tricky because we don't have any actual coursing above this line to snap to. So one thing we could do, again, there's multiple different ways. We could draw guidelines, we could measure things, or I could just set this material back to brick common, and that way this extrusion itself is coursed out, and now I can just pull that top down. Or you know what, I'm going to use my align tool because it's harder to do it with that button. Choose that, and now let's set it back. So I set it to 2 bricks high, and now I can set this back to precast concrete. Hit OK, and there's our top extrusion. Okay, so now that I got those caps on my fin walls, now I can come in here and do the bands. I'm not going to go through all of these because I've kind of shown you how to do this, but I'm just going to walk you through just a few more. So again, we'll look at our final deliverable. We'll see that we're coming down 1'4", then a series of 1 brick course, 2 brick courses, 1 brick course, 2 brick courses, and 1 brick course. What we're going to do is we're going to select our family, edit in place, split face, and we're going to split this face. And you know, it's easiest to just count brick courses. So 1'4" is actually 6 brick courses. So we can use our pick lines tool. So 1, 2, 3, 4, 5, 6. Make sure you're picking a horizontal line. So that's our first line. Now again, we're just going to pick 1 brick course, 2 brick courses, 1 brick course, 2 brick courses, and 1 brick course. And I could do all the rest for this particular surface, but I'm just going to do these for now just to give you a little bit more practice in the video. I'm going to hit the green check mark. Now I can come back and paint. Now I can already see that some of these are going to be off, so I'm going to paint that and this one, and just for the heck of it, paint this one, brick common 1. So let's paint those. Then we can come in and find our precast. So we're going to do that. Oops. You have to be really careful with where you're clicking. So find precast and click there. Make sure that the blue highlight is surrounding the face you want. And there we go. Now we have those bands in place. You can see here that this one isn't on coursing. So again, I could come back to brick common. Okay, so that didn't work. So now I'm going to use my align tool and align that coursing. Double check at the bottom to make sure it's still aligned. And again, you'll have had to split this at the bottom and anywhere else that the instructions say to split to get your materials there. So I'm not going to do the rest of these splits and faces on screen because there's a lot to do. After I wrap that up, I'll come back. Okay, so I've split all my faces, painted all my materials on all the fin walls, and you can see the results here. One thing to remember, don't forget to do the back faces of this. This one's easy because it shows up in the north elevation, but the back of the west fin wall and the back of the east fin wall are a little bit harder. I just did them in a 3D view. You have to be a little bit careful about how you're aligning and selecting things. You could also cut or place a new elevation or even cut a temporary section through somewhere where you would see those. So just a reminder, don't forget to do those back sides. So moving on, the next thing I'm going to do is create my roof. The roof that I'm talking about is my membrane roof. So we're going to do that inside of Revit with the architectural roof tool. We are going to create it from this steel truss insulation on metal duct EPDM. Again, that's mostly because it has most of the parts and pieces for our roof. So I'm going to go to the roof plan. I'm going to go to architecture roof. So we already have our roof, our structural roofs, right? We have this concrete slab here, this metal deck here, and we have a metal deck down here. So we are going to create architecture roof by footprint. We are going to change this to steel truss insulation on metal deck. We're going to edit type, edit structure, and what we'd like to do is we just want the EPDM and the rigid insulation. Now, if we try to delete both of these layers, we can't even delete this. We have to always have something within the core boundary. So we're just going to move our rigid insulation down using that down button into the core. Now we can delete other structural layer. We're just going to keep this as a thermal air layer. It's going to be 4 inches of rigid insulation, and we're going to leave the roofing EPDM above the core boundary and at a 1/4 inch thickness. Hit OK. I forgot to rename this, so I'm just going to come in here and I'm just going to say insulation. It technically is over metal deck, but we are not showing the metal deck as part of this assembly. It's already in the structural assembly. So now we hit OK. We're going to start up here. We're going to do the roof here. So that is at the roof level with the 0 offset. Now we're going to come down here. We've got that. And we want to look at our final deliverable. What we can see in our roof plan is that this upper roof is actually separated into 2 separate drainage areas. So these are flat roofs. However, they do slope to an internal drain. So there's one drain here and there's one drain here. So essentially what we have to do is create 2 separate roofs. So we're going to create this one here. Most people would think, oh, we're going to create this L-shaped and we're going to jog it around here. That's not what we're going to do, because that's going to cause issues when we start to slope this tapered insulation for this roof. So what I'm going to do is I am going to choose the pick walls button. I'm going to make sure I'm not defining slope, because this is a flat slope wall. I am not extending to the wall core. And I'm going to choose this wall towards the inside, that wall towards the inside, this wall towards the inside. And I can't use this because it's not a wall, but I can use my pick lines tool. It is to the bottom face of that wall. And now I can simply trim all these lines together. So I'm using the TR or trim to corner command and creating my outline. Now again, you'll notice that I'm going right over this roof. That's intentional at this point. I'm going to hit the green check mark, and now I have a roof. If I go to 3D, I can see that I have this roof surface here. Now I also like to go to the roof plan, and I like to create a section through here. Now this is just sort of to look at this at this stage, so I'm going to go there. I'm going to bump this up to, I don't know, 3/8, just so that I can see maybe a little bit more detail. Change this to consistent colors. And you can see that I have an insulated roof right on top of my roof deck. But we need this to slope towards the internal drain. So we go back to the roof plan, we select this roof, and we're going to have to add a point in the middle where the drain is, and we're going to have to raise the corners of this up by a certain amount to create our intended slope. So we're going to go back to the final deliverable, and we can see that our slope is 1/4 inch per foot. Now to get that, we have to figure out what our longest run is. If we measure this horizontally, we get 45 feet 10.5, and if we measure it vertically, we get 40 feet. So this is the longer dimension. So we want to make sure that we have a 1/4 inch per foot slope for the longer dimension, and that will ensure that our shorter dimension will be more than a 1/4 inch per foot. So I'm going to take 45 feet 10 and divide it by 2, because I only have to slope halfway to the center of this. Half of 45 is 22.5, which would be 22 feet 6, and half of 10 is 5. So 6 plus 5 inches is 11, so we get 22 feet 11 inches is half the distance. We are going to say, let's just say 22 foot 6. Because again, if we keep the distance shorter, we'll ensure that we will have a steeper slope. You know, it might be slightly over 1/4 inch per foot. So that's 22 feet 6, or 22.5 feet. If it's a 1/4 inch per foot, we can take 22.5 times 0.25 for a 1/4 of an inch, and we get 5.625 inches would be our rise. I'm going to just bump that up to 5.75. That'll be on this, again, on the safer side. So our longest dimension we're saying is 22.5 times 0.25, and we're rounding that up to 5.75 inches in rise. So what that means is the corners of this roof need to be 5 5.75 of an inch taller than my roof drain. So to do that, I'm going to select this roof, and I'm going to come up here to my contextual ribbon, and I'm going to modify sub-elements. Now, the sub-elements are basically points that I can create, or split lines. I can do all sorts of things, but the default is the corners of my roof shape. You can select those and you'll see that they have an elevation of 0. So 0 is essentially the top of my roof, or the top of my EPDM surface. So 0 is essentially what I want to drain to. So I need to raise this up to 5.75 inches. And I'm going to do that for all of these. And unfortunately, I can't do multiples. I have to do them one at a time. Now, one thing is, did I make that inches or feet? I did make that 5.75 inches. Make sure you do inches, the inches symbol. Otherwise, it'll be, ridiculously thick. All of these are 5.75. If I go to my section, you will see that it has raised this entire roof up by 5.75 inches. So now I have the space in between. That's because I forgot to do something. If you look at our instructions, again, this is why it's important to look at every detail of these instructions. I forgot to check this variable property in my roof type. So I'm going to select this roof. I'm just doing this in section. I could also do it in the roof plan. Edit type, edit structure, and my rigid insulation, its thickness needs to be variable. And once I hit OK and hit OK again, you'll see now that the thickness takes up the rest of the room after I've modified the height of this. So now I have a really thick sandwich of insulation and EPDM on my roof. So I'm not quite done. I need to slope this now. So what I'm going to do is I need to find the center of this. Quickest way to do that would be with a detail line. So I'm going to hit detail line, or DL, and I'm using a detail line over a reference plane because reference planes don't have center points, and that's what I'm trying to find. I'm trying to find the center point. So now with that detail line there, I can go back, select this roof, and what I'm going to do is hit add point. And now I can create my own point on this, and I'm going to choose the midpoint of that detail line that I've created. Maybe I can't. Oh, I hit escape too many times. I need to edit the roof, modify sub elements. Yeah, select this, set that to 0 now. It's going to create these split lines on its own, so I can hit escape now. Now I do want to delete that detail line that was there, and I can look at this in 3D view, and I can see it's hard to tell because it's it's a 1/4 inch per foot, but this is sloping down to that point. If I look again at this section, now you can see this roof is sloping down to that central point. So that's how we do flat roofs with tapered insulation in Revit, or at least that's the best, quickest, fastest way I've found to do them. Now you're going to say, well, we still have this chunk of roof hanging over here, and that is true. Now the reason that I don't trace this outline is then what happens is I end up having to figure out where this point is here, right? And figure out through that math, what its rise over run and all that is. And that gets really complicated. And it creates a really complicated roof shape. So we don't want to do that. We keep it simple. We just need one roof drain, 4 triangles. That's it. To remove this section, what we can do, create a roof opening. So we'll go to architecture ribbon, openings panel, and you'll see vertical openings. Click that button. This is a lot like the window opening on the wall, only it's a horizontal opening in a roof. And we're going to pick, so it says pick the roof that we want to create the opening in. So we're going to select this roof, and we are going to choose the rectangle tool. And I'm just going to go from the inside corner of that parapet wall out to here. Make sure you are selecting those points, otherwise you might be left with a tiny little sliver of roof out here. Hit the green check mark, and it literally cuts out that portion. It creates sort of a void in the roof. And if you want to be absolutely correct, the roof is still going through our fin wall, right? So if we wanted to be correct, we would go back to architecture, create another vertical opening, select the roof again, and this time we would, I'll just use the pick lines tool. So I'll pick these lines. And then I can trim these lines. Now I do need to close this loop. Now I could do that right at the edge and it would give me satisfactory results. I could also go over the edge. It doesn't really matter. As long as you at least meet that edge, it should cut all of the roof out. But you don't want to be off that edge, or again, you'll be left with a little sliver of roof. So we can hit the green check mark, and now when I select that, you can see that the outline goes around the fin wall instead of through it. So that's how you create the flat roof up here. I'm not going to show you how to do the roof On the mechanical area, that's essentially the same. Sorry, I need to go to the final deliverable. The only difference there is that the roof drain is in a little bit different of a spot. And again, to figure out the slope on this one, I would just say, estimate this to be, I don't know, 2-3 feet off of the face of the wall, but centered this way. You can do this one on your own as well. Again, keep in mind that you'll be doing a rectangle and then cutting this corner out. This mechanical roof, that can just be done with a simple rectangle. You don't have to create any roof openings. I am going to show you this one, however, down on here just to do some more roof practice. What we're going to do again is roof by footprint, really I should say. It's going to be EPDM. Now this base level is 14 feet 1. It's going to be at the top of my metal deck for this patio roof. And again, for this one, I'm just going to pick lines. I'm just going to pick these lines. Now again, now that we have these parapets in place, make sure that the line you're picking is in fact the face of the roof. Or sorry, the face of the wall, not the face of the parapet. For instance, that's the face of the parapet. And see that line back behind it? That is the face of the wall. And it will find it even though we can't see it in this view. You just kind of have to be careful that you're making sure that there's a tiny little offset there. And again, I'm trimming these to the corners. Now this line, and this line are all right on the face of that roof deck below. I made sure I wasn't introducing any slope to these. I can hit the green check mark. I will look at an east elevation to see if I got that right, and I did. It was 14.1. So that puts our roof right above that deck. Now again, let's look at our final deliverable. This is sloping down from here. So this is our longest slope. It's also going to slope here, here, and here. But that means that my high edge is along this line here. So that means I have to determine how far from this edge to this edge. So that's simple enough. I measure. It's 7, 11, and 5/8. Let's just call it 8 feet. Again, a longer length will give you at least a 1/4 inch per foot. And so we're going to do 8 feet times 0.25 inches or a 1/4 inch, and that's going to give us 2 inches. So I'm going to select this roof, modify sub-elements, and that means that this corner should be 2 inches high. This corner should be 2 inches high. Now, you'll notice that it's going to say, okay, that makes sense. This whole thing is sloping this way, and this is going to slope this way, and this is going to slope this way. Now, again, these are shorter runs, so these are going to be greater than 1/4 inch per foot, but we're getting at least a 1/4 inch per foot here. The problem is that we do not want to just throw water up against this edge here, so we have to create sort of a cricket. So we need to create this line here. So to do that, we need to split the roof surface vertically here so that it slopes one way this way and one way to this valley, which will then get our water away from this face. So to do that, we can use split line, and I'm going to simply click there and click perpendicular there. And again, this point here is going to also be at 2 inches, which is our high point. So I can hit modify sub-elements, select that point, set it to 2 inches. So you can see that these 3 points now are our 2 inch points. This is 0, and this is 0, 0, and 0. Now if we change that, now the only problem is that didn't seem to create that split there. Let's look at this in 3D. Why didn't it do that? So it is sloping down this way and this way. It looks like we might have to add that split in ourselves. So let's go back to the roof plan, select this, add another split line from here to here. So, and then we can select it, modify sub-elements. So that's 2 inches, that's 2 inches, that's 0, That's 0. So this is, it's figured out that it wants to put it at 1.5, but we're actually going to set this also to 0. And hit escape, go to my 3D view, and now you can see how that's working. It's sloping down to 0, so this edge is still 0, this edge and this edge are 0, and then those 3 points are at 2 inches. And that allows this smaller piece of roof to drain to the edges, not to an internal roof drain. Another thing that you'll have to do once you place all of your roofs, now I've only placed a few, is put in your roof slopes. That's easy enough. They're kind of automatic. You go to annotate, spot slope. You can put these in. Now that one you kind of have to modify after you place it. It's a little too big to fit there, so we'll just do that. And as you can see, the accuracy of the spot slopes, I don't know, I guess I could go in here and edit and look at my units format, and it's basically rounding to the nearest eighth of an inch. And even though we didn't get these perfect, we fudged these by a few inches here and there, they will, or they should, round to the closest eighth, which in our case is a 1/4 inch per foot, which is exactly what we wanted. So again, I'll go back to annotate, spot slope, and you can see here that these are all coming out to 1/4 inch per foot. So don't forget to do those for your other 2 roofs once you're done. Okay, I'm going to move on to the fascia for this roof. This roof actually has a bit of thickness to it. To get that thickness, we are going to create a metal fascia. Now, we used the fascia tool back in ARC 110, and we used it to just create a regular wood fascia. But what we need to do is load in the fascia from, it's called Fascia Flat Roof. I think I may have that loaded in. Let me just double check here. Okay, so I've got that opened up from Vanco Hall. I'm going to simply load that into my project and close. So now I have that fascia. And if I go, the easiest thing to do is go to a 3D view, and I can go to architecture, roof, but I'm going to click the down arrow, roof fascia. Right now I only have one type, and that's the 1x12. So we're going to edit type. I'm going to rename this one fascia flat roof, hit OK, and now the profile, which is by default just a rectangular profile, I'm going to change this to fascia flat roof 1'4", the one that I just loaded in, hit OK, and now all I have to do is select the edges of my roof, and it creates that fascia. The next thing I have to do, I need to create a soffit for that roof as well. So if I look at this in 3D, I can see that, this is essentially just a piece of metal hanging off here. So I need to fill in that space to get down to the bottom of that fascia. So to do that, I'm going to go to a second floor ceiling plan. Now I've deleted my ceiling plans. You might still have yours. If you have deleted it, you can go to view, plan view, reflected ceiling plan, second floor, hit OK. Otherwise, just open it from your project browser. Now what's happening is we're looking at the again, this is a reflected ceiling plan. So we're looking at the underside of this soffit. So now I'm going to go to the architecture tab, roof with the down arrow, and I'm going to say soffit. Right now I've only got this generic 4 inches, so I'm going to edit that. I'm going to look at my final deliverable, and I'm going to create one called exterior soffit. So I'm going to rename this exterior soffit. I'm going to edit the structure. I basically have a 2.5 inch metal stud structure, and then I have a 1/2 inch of plywood sheathing. I have an air infiltration barrier, and then a 1/2 inch of gypsum wallboard. So we're going to change this to metal stud. So I'm just going to type metal stud layer, and that was, I believe, 2.5 inches. So then we're going to insert some layers. So we're going to move those down to be below the core boundary. So I just need 2. No, I need 3, so I'm going to insert one there. This is going to be a substrate. It's going to be a 1/2 inch, and we're going to change this to plywood. This is an air barrier, so air infiltration barrier, and that is a membrane layer, so that is a 0 thickness layer. And then finally, our finish 2 layer is going to be gypsum wallboard, so I'm just going to type GWB, and that should find gypsum wallboard. Hit OK. That also wants to be 1/2 inch. Hit OK again. We're going to pick lines. So we're going to pick the exterior faces of those. It's hard to tell. I think all of these lines are part of the fascia. Actually, no, that's the roof edge. So I do want the roof edge, so the interior line on those faces, and then that line there, and then the line of the wall there. We do have to trim these together. I think these are already trimmed. Height offset from level, I'm just going to do 8 feet for now. I will probably have to modify that. Let's see what that looks like. Yes, that is way too low. So we could go to an east elevation, and we would like the bottom of this to align with that course line. So we can align there, the bottom of that soffit. And again, if we go back to a 3D view now we have a soffit at that bottom edge. So that's how we create the exterior soffit for that patio roof. Finally, the last thing that I'm going to show you in this video is how to create my patio floor. So we need to do two things. We need to create a new floor type, and that new floor type is going to reference a new material called pedestal paver system. So what we're going to do is let's start with the material first. So we're going to go to Manage Materials. I think I started with precast because these are very similar to a precast concrete material. So let's go to precast, and we're going to choose that, and we're going to come down here and click the Duplicate Material and Assets, and then we're going to rename this Pedestal Paver System. I think that's what I have it called. The surface pattern, what we would like to do is create two surface patterns. Background pattern is going to be sand, and the foreground pattern is going to be 24-inch square. That will give us not only a sandy looking texture on the surface, but also it's going to break it up into these 24-inch squares, because this is basically a kind of like a paver, right? It's only 24 by 24. Our background we're going to change to sand, so hit OK. And then our foreground, it's going to be a model pattern because we want this to always be 24 inches no matter what the size. If we did it drafting, it would change depending upon the scale. So we want it to be model, and we could see if we can find any tiles that are close to 24 inches. I do not see anything. So I'm going to start with 4-inch tile. I'm going to duplicate. I'm going to call it 24-inch tile, and I'm going to simply change the line spacing to 2 feet and 2 feet. Hit OK. Hit OK again. Now I have a 24-inch tile material, or sorry, a 24-inch tile surface pattern applied to my pedestal paver system material. So we can hit OK. Now we have that ready to go. I need to look at this pedestal system, and it's literally just one thickness of 2¼ inches. So we could do this with a default floor. So let's go to Architecture, Floor, and we're going to change to, let's just go with generic 3-inch. Edit type, edit structure, make it 2½ inches, and change the material to our new material that we just created, pedestal paver system. It's actually selected already. Hit OK, hit OK, hit OK again. I'm not in, let's go to my second floor plan, and we are going to pick walls. Let's make sure I have all this right. So my level is actually second floor with a 0 offset, and we are going to make sure this offset is 0. We're going to pick that, whoops, pick that wall. Nope, I can't pick that wall. Oh, because I have extend into wall core. So let's undo that. Uncheck extend into wall core. Now I can select that face of the wall. Here I don't have a wall, so I'm not going to choose that. I'm going to choose that wall, and this wall. And then we can use our pick lines tool to get the edge of the fin wall. And we want the outside face of our curtain wall, or our mullion. And now we can trim this to the corners. Whoops. Trim this corner to there, that corner to there, and finally this one to there. Hit the green check mark, look at it in 3D view, and now you can see that now we have a pedestal paver system, which is not only has sort of that sandy surface, but it also has the actual 2x2 tile paving system to it. So at this point, that wraps up everything I want to show you for this video. I will point out these section markers I have on the drawing, but we don't actually print these sections. So if you get to this point in the video, don't worry about that. We'll tackle that in another assignment. Thanks for watching.